We thought we knew Venus, our sister planet, a hellish, lifeless world where lightning tears through the atmosphere and metals melt on the surface. But new discoveries are forcing us to completely rethink everything we believed about this mysterious world. Beneath the veil of acidic clouds and crushing atmosphere lies something unexpected, something hidden deep beneath the scorched surface. We're talking about networks of tunnels stretching for dozens of miles, gigantic lava tubes that could conceal not just molten rock, but perhaps life itself. This is the story of how scientists discovered that Venus, the planet we thought was dead, might be far more alive than we ever imagined. To Part 1, the planet. We thought we knew Venus has always seemed like Earth's darker twin. Same size, same basic composition. But that's where the similarities end. On the surface, Venus is a scorched hellscape. Temperatures reach 869 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is more than 90 times that of Earth. The air itself could crush a spacecraft like a tin can. Thick, opaque clouds drenched in sulfuric acid constantly blanket the planet, reflecting radar signals while blocking all visible light. Only a handful of probes have ever survived on the surface, and even then, only for a few minutes. In 1975, the Soviet lander Venera 9 gave humanity its first look at the planet's rocky terrain. Later in the early 1990s, NASA's Magellan orbiter mapped a world astonishingly dominated by volcanism. Vast lava plains, massive shield volcanoes, mysterious circular structures known as coronae cover Venus's geologically young surface. In fact, Venus has more volcanoes than any other planet in our solar system. For decades, scientists believed that all of Venus's volcanoes had gone cold. Without evidence of plate tectonics to release internal heat, many assumed that the planet's interior simply simmered beneath a motionless crust. Until around 500 to 800 million years ago, they theorized it erupted in a catastrophic global resurfacing event. A planetary volcanic cataclysm that buried Venus beneath fresh lava. After that, Venus was thought to have fallen into geological silence, dead both inside and out. But that view was about to change. Part 2. A planet comes back to life. New evidence began to challenge everything we thought we knew. Magellan's radar mapping revealed a geologically young surface, on average only a few 100 million years old, with surprisingly few impact craters. Could some regions be far younger? Was it possible that this global resurfacing never truly ended? The first jolt came from an unexpected discovery. In 2023, researchers reviewing 30-year-old Magellan images noticed something extraordinary: changes on Mont, one of Venus's giant volcanoes. Two radar scans taken just a few months apart showed that the volcanic vent had expanded and a new lava flow had appeared. In other words, Magellan had accidentally captured an eruption occurring in 1991. It went unnoticed for decades, but once discovered, it became sensational news. Venus is still erupting today. This wasn't just important, it was revolutionary. The first direct evidence of modern volcanism electrified planetary scientists around the world. If one volcano is active, how many others might there be? Suddenly, Venus no longer seemed quite so lifeless. But one set of features stood out sharply and drew significant interest: the coronae. Enormous ring-shaped structures that cover much of Venus's surface. Scientists believe these volcano-tectonic rings form when hot plumes of magma rise and then collapse, leaving behind a circular pattern of ridges and fractures. Could these be the hotspots of Venus's lingering internal heat? In 2025, a team led by Gail Cioli and Anna Goller re-examined the Magellan data with fresh eyes and new computer models. They found that 52 out of 75 coronae showed signs of tectonic activity today. Most of them are surrounded by trenches, indicating that old crust is sinking around the ring while hot rock rises in the center. Miniature circular subduction systems, tiny rings of fire on a planet with no plate tectonics. The conclusion was dramatic. Venus is not a dead world at all. Its crust is moving slowly in isolated spots, but still moving. And where there is movement, there may also be earthquakes. At the same time, another study showed that the fractures surrounding the corona likely cut all the way through the crust down to the upper mantle. Stresses deep enough to potentially trigger Venusian earthquakes that an orbiter could detect. All of this painted a picture of a planet with ongoing internal activity, not the inert rock we once assumed. But the biggest discovery was yet to come. To Part 3, the discovery of lava tubes. Yet these discoveries were made using data gathered decades ago and through clever inference. What else might Venus have hiding in those grainy radar maps? The answer lay not only in its volcanoes, but in strange surface patterns hinting at something lying just beneath. We're talking about lava tubes. Lava tubes form when the surface of a flowing lava stream hardens while molten rock continues to move beneath it. Eventually, the lava drains away, leaving behind a hollow cavity. Such tunnels exist on Earth, for example, in Hawaii. Even larger ones are found on the Moon and Mars, with diameters up to 1 mile and lengths exceeding 20 miles. Scientists suspected, if they exist on other planets, why not on Venus, where volcanism is still alive? Yet confirming this proved difficult. Why? Venus's surface is hard to observe. We have to rely on radar to see through its clouds. And while Magellan's 1990s radar was revolutionary, its resolution was limited. Any skylight openings into caves would be small and easily missed in coarse data. Still, scientists noticed suggestive hints. Chains of pits and shallow depressions scattered across the planet's great volcanoes. Were these caused by tectonic fractures ripping the crust apart? Or were they collapse pits from drained lava tubes? Until recently, no one could say for certain. And this is where Dr. Barbara Dafoe and her colleagues entered the scene. In 2025, at a major planetary science conference, they announced the first convincing evidence of lava tubes on Venus. Their approach was clever. They analyzed radar and topographic maps from past missions, focusing on Venus's largest shield volcanoes, each over 60 miles in diameter. On several volcanoes, they discovered distinctive patterns, winding chains of pits descending the slopes. Unlike straight, evenly spaced tectonic fractures, these pits meander smoothly down the slope as if a river of lava had once flowed beneath the surface. The team identified 4 distinct examples of these winding chains of pits. Importantly, none of them were associated with known faults or rift zones on Venus. In each case, the pits varied in size, consistent with sections of a cave roof collapsing. Smaller skylight pits alternated irregularly with larger collapsed segments, just like the fallen portions of a lava tube ceiling. And the pits always lined up along the steepest slope of the volcano, exactly where a lava flow would carve its tunnel, draining downhill. This was irrefutable evidence. It's extremely unlikely that tectonic processes could produce such elegant winding chains of collapses that obediently follow the terrain. Instead, they mirror features we see on Earth, the Moon, and Mars. By measuring the width and depth of these pits, Dafoe's team confirmed that the numbers only make sense if empty space lies between them. The pits were not deep enough to be impact craters or steep tectonic faults, yet they were deep enough to match the expected diameters of underground tunnels. A decades-old hypothesis had finally become fact. Venus harbors extensive caves formed by ancient lava flows. But the surprises didn't end there. Part 4. Giants beneath the surface. It turns out that these Venusian lava tunnels are enormous. In terms of volume, they far exceed typical lava tubes on Earth. In fact, they rival the colossal lava caves of the Moon. Usually, a planet's gravity influences the size of these structures. Lower gravity allows tubes to grow larger without collapsing. Earth's strong gravity yields modest tubes. Mars's weaker gravity allows for bigger ones. And the Moon's very low gravity produces the largest known tubes in our solar system. By this logic, Venus, with gravity nearly equal to Earth's, should have Earth-sized tubes. Yet our sister planet breaks this trend. It exhibits very, very large tube volumes. As Dr. Defoe reported, the team concluded that Venus may host some of the largest underground cavities in the entire solar system. Why are Venus's lava tubes so enormous? This is a mystery that currently fascinates planetary scientists. One hypothesis suggests that the planet's extreme environment plays a crucial role. Intense atmospheric pressure could help support the tube ceilings, keeping the caves stable despite the planet's strong gravity. Meanwhile, the high surface temperatures may allow lava to remain molten for longer, letting it flow farther and carve longer tunnels before cooling. If these tunnels have indeed been preserved beneath basalt, their ceilings could contain sealed pockets of ancient gases, dust, and volatile compounds, time capsules from earlier atmospheres. The mineral surfaces inside such cavities might also preserve chemical gradients long erased on the surface. Could these protective volumes have harbored prebiotic chemistry? Could they have sheltered microbes? The Part 5. What lies beneath? The search for answers. So, what would it take for us to truly look inside? The discovery of this underground labyrinth is just the beginning. To truly understand these structures, scientists are eagerly awaiting new missions. One of the most anticipated is EnVision, the European Space Agency's orbiter scheduled for launch in the early 2030s. EnVision will be equipped with a powerful ground-penetrating radar designed to probe the planet's interior and detect cavities several hundred meters beneath the surface. It will directly scan the lava tubes and map their full extent and detail, likely confirming just how vast and deep these tunnels really are. In addition, NASA's Veritas orbiter is planned for launch, and it will also employ advanced radar and gravity mapping technologies to revolutionize our understanding of Venus's geology. Of course, studying the planet up close remains a tremendous challenge. Surface temperatures of 878 degrees Fahrenheit and pressures at 92 atmospheres, like a furnace, will destroy most landers within minutes. However, if a robotic probe could enter a lava tube through a collapsed skylight, the surrounding rock could provide some insulation from these hellish conditions. This could potentially allow it to survive longer and gather data from inside these underground structures. Scientists are already working on specialized equipment designed specifically to withstand Venus's extreme conditions. Probes with reinforced heat shielding and advanced sensors could potentially explore these caves. The data they could gather would be invaluable. Rock samples, atmospheric composition inside the tubes, evidence of chemical reactions, and potentially signs of past or present microbial life. Get in Part 6. Rethinking our neighbor. These discoveries force us to rethink why Earth and Venus, so similar in size and composition, took such radically different paths. Today, Venus appears as a vision of hell. Yet it's clearly geologically active, far from the dormant world we once assumed. It also serves as a warning for Earth, a climate gone out of control, a surface reshaped by volcanic activity, yet trapped beneath a suffocating lid. By studying Venus's past and present, scientists hope to learn whether it ever had oceans or temperate periods, and how it fell into decline. This matters for our future. It reminds us how fragile planetary climates can be, how quickly conditions can spiral toward catastrophe. Looking beyond our solar system, these findings also affect how we interpret distant worlds. Telescopes are discovering numerous Earth-sized exoplanets that could resemble Venus, shrouded in clouds and baked under thick atmospheres. If our neighbor still bubbles beneath its hostile surface, some of these distant exo-Venuses may be more dynamic than they appear. There are also practical implications. On the Moon and Mars, lava tubes are considered natural shelters for future explorers, caves protected from radiation and micrometeorites. Venus is a far harsher world, but the discovery of such formations adds intrigue. If technology ever allows, these tunnels could even serve as ready-made bunkers, offering protection from the planet's extreme conditions. Part 7. The philosophical question. Venus, the bright evening star, has long concealed its face and kept its secrets. Now we know it is a world of fire and sulfur still smoldering beneath the clouds. Yet much remains unseen. And perhaps beneath this hell lies a story we never expected to find. The discovery of these lava tubes changes our perspective. It reminds us that worlds we thought were dead and lifeless might harbor secrets, hidden structures, hidden possibilities. Could ancient microbes have survived in these protective cavities? Could chemistry occur there that we haven't imagined? Could Venus's underground still be active? We don't have answers yet. But for the first time in decades, scientists are taking these questions seriously. The universe is far stranger than we assumed. Planets we wrote off as completely hostile may harbor wonders. Our understanding of habitability has been too narrow, too Earth-centric. Venus teaches us that life, or at least the chemistry that precedes life, might emerge in places we never thought possible. Part 8. Conclusion. The future of Venus exploration. For now, as new missions prepare to pierce the clouds and draw closer to Venus, we stand on the threshold of discovery. We're full of anticipation, and perhaps a touch of unease. What we find could rewrite our understanding of how a planet so similar to Earth took such a catastrophic turn. It could also expand our vision of where life, or the potential for life, can exist. Venus is gradually coming into focus, alive, formidable, full of deep, dark secrets. Uncovering these mysteries will not only shed light on the fate of our nearest neighbor, but also help us better understand the history of our own planet. More importantly, it reminds us how much we still have to learn. The cosmos is full of wonders. Worlds we thought were simple are revealed to be complex. Planets we dismissed as dead are revealed to be dynamic. And the question remains, what else have we missed? What other secrets are waiting to be discovered? If this video intrigued you, subscribe to the channel. We have many more videos coming about space, Venus, and the nature of worlds beyond Earth. Thank you for watching. Keep looking up.